As we're working with percent increases and percent decreases, a useful strategy is to use what are called tape diagrams. Maybe you've seen these before, maybe not, but I really like them because it doesn't actually matter what your numbers are, and that's why percentages are so great, is that we can sort of think about this as a whole and then we're adding in certain percentages. So a general rule is that whenever you see the phrase percent increase, essentially what you're doing there mathematically is you're taking 100% of whatever was initially and then you're adding in some number of percentage. So like I say, something increased by 20%, well, then I would just take 100 plus 20 and be 120. If I have a percent decrease, I'm going to go the other way. And so this is where maybe I say, oh, something decreased by 60%. And so I can take 100% of the original thing minus whatever number they tell me to subtract. So like 100%, something decreased by 60%, I'm going to take 100 minus 60. And then how we can use tape diagrams is these four representations here all connect to this diagram. And so we can think about this value right here, the shaded part that says X, let's call that 100%. And so I can see that 100% they have divided it into four equal parts. So like this is 1/4, this is 1/4, this is 1/4, and this is 1/4. So I know that this section over here is plus an additional 1/4 because it's the same size as these other sections over here. And so I can remember from converting fractions to decimal that 1/4 is equal to 0.25, which is the same as 25%. Remember, to convert from decimals to percentages, I'm just multiplying by 100, which is moving my decimal place 2 points over there. So I could say that this is now 125%. So like this one right here is 100% plus 25%, right? This little section over here represents that 25%, or 1/4. Also, because I can see now, I'm going to go back to this statement I put over here, this percent increase is a 100% plus that number. Well, that's an increase of 25%, so this one also would work. When we think about this statement in here, y equals 1.25x, well, what they're saying here is that this total length of y is whatever 125% is, or 1.25 of x. Remember, we can go the other way from percentages by dividing by 100, so I can go back this way to get 1.25. So that one also works. And then this is the one we sort of started with. We noticed that this x section was divided into 4, and so 4/4 is 1, and then I'm going to add in 1/4 more. And so all four of these work. So tape diagrams are a really useful strategy to sort of visualize percent increases and decreases. And so we're going to look at a couple of these problems down here where we're asked to match each situation to a tape diagram and be prepared to explain my reasoning. So I think I have two diagrams here. It looks like diagram A and diagram B. And so one option here is compared with last year's strawberry harvest, this year's strawberry harvest is a 25% increase. So I'm going to underline increase because it's important. So that tells me that a new tape diagram should be longer than my original one. And so if I look at this guy here, it says this is 100%, and then this year is 25% increase, so it's 25% more. So that would work for this one. So general rule is whenever you see percent increase, your tape diagram, your new tape diagram should be longer than the original one. Conversely, if you see a longer tape diagram than the original one, you know it's referring to a percent increase. This one here says this year's blueberry harvest is 75% of last year's. That's going to tell me my tape diagram should be shorter, and so I'm going to do 100% minus 25% to get to me that 75. And so this one here would work because last year, this is again represents my 100%, and I'm going to subtract out that 25%. So I could label this one as B. Compared with last year, this year's peach harvest decreased by 25%. That's going to be that same one here. These are sort of related to each other, right? This one said, okay, I get down to 75%. This one just tells me how much I decreased by. So this one would also be B. Again, I know that because that hint of decreases tells me that my tape diagram should be shorter. And this year's plum harvest is 125% of last year's plum harvest. So, okay, 125%, that is more than 100%, so my tape diagram should be longer. That one's going to be A as well. If I was given the problem of asking me to draw some tape diagrams, A useful strategy that I will do is just start by drawing a box, and it doesn't matter how long it is. But I personally like to divide it into 10 sections because it's really easy for our brains to count by 10 because we are a base 10 society. I wonder why, right? We have 10 fingers, duh. So if I divide this into 10 equal sections, so 1, 2, 3, 4, that's roughly even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Now it's really easy when I think about, okay, it increased by 40%. So we're going to start, this is my 100%. Now that I've divided this into sections of 10, I know if I know I need to add 40%, that means I just need to add in 4 more boxes. So like I need to add in 1, 2, 3, 4, that amount of length. And so I'm going to say that's about right. And I can color that 1, 2, 3, 4. Great. And so now I could shade those in, right? And that would be my new, no, that would be the 40% I added in. And so then this whole entire length is the new number of ducks, right? This was my old number at 100%. I added 40%, and now I have this new total value. If I've got this one here where it says the number of mosquitoes decreased by 80%, that tells me my tape diagram needs to be shorter than my original one. And so I can simply draw my box again, and I'm going to divide it into 10 sections because that's easy for my brain to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So now this would be my original amount, right? Which is 100%. And I need to decrease 80%. So I need to take off 8 of these boxes, right? Here's the 80% I'm going to decrease. This guy right here is my 80% decrease. And so what I'm left with is this 20% new right here. So I really like tape diagrams as a way to visualize percent increases and decreases because without knowing any numbers and just knowing percentages, I can visually represent that math. So big takeaways from this lesson. 1, percent increase is always going to be represented by 100 plus a percentage, and a percent decrease is always going to be represented by 100% minus that percentage. And we can use tape diagrams by drawing a box and maybe dividing it into 10 sections or maybe quarters, whatever sort of makes sense with the problem, dividing it into sections and then adding or subtracting based on your percentage increase or decrease.